All right, so we are live. Got my review up. Okay, so let me go into student preview mode. This is on Blackboard and whatnot. Let me go into course content. So right off the bat, there's that capstone project poll I was telling you about. It's just a one-question, quiz. Just whenever you get a chance to do it. I've got a link to the YouTube playlist where all these videos are ultimately going to get uploaded. And here's the folder for the quizzes. Here's the folder for the exam materials. So I want to take a second and go through the exam materials section. And so there's a couple of links here that are worth looking at. So let's take a look at the first one. This is my NCES. This is the account that you will create in order to sign up for your exam. NCES stands for the National Council of Examiners for Engineers and Surveyors. They're the ones who write the exam. And so the same FE exam that you take in West Virginia is the same one you take in Florida, Alaska, Nevada, everywhere across the country. Okay, so it's the same test, and they're the ones who create the exam. So I'm going to actually pull this up now. Let me see if I can remember my password. I think that's right. Okay, that wasn't right. That wasn't right. I hope I don't block it out. Oh, I got it. All right. So this is what it looks like when you log into your account. Now for me, I took my FE exam before this NCES account was created, so my FE exam doesn't show up, but my PE exam does. Whenever you pass the exam, you'll pass it, and then there'll be this like result notice. And so what NCES does is they create a specific URL for you to indicate that, okay, you pass, and this is your sort of exam verification. So anybody that passes an exam, they maintain that storage of record that you passed. Now, right off the bat, I can tell you that if licensure is a path that you're going to take, then your NCES account is something that you do want to maintain pretty regularly. For example, so I got mine last year, and so one of the things that you can do on your account is track your continuing education. And so professional engineers need a certain amount of continuing education every so often, and so you can store that. It'll store all of your completion certificates and so on and so forth. So it's a pretty nifty tool. Also, if you're planning on getting licensed in multiple states, which is more common than you would think for civil engineers, because if you're working at an HNTB, well, HNTB doesn't care about only working in West Virginia. HNTB cares about making money. And so if that means having engineers on staff that are licensed in 12 or 13 states, then that's what's going to happen. So what NCES will do is create a single user file that stores your transcripts and your work history and all that stuff. And so if you need to get licensed in another state, you just forward that off. And there's even a link for multi-state licensure. I haven't done anything with it because I'm not planning on getting licensed in multiple states, but you can go on and submit your transcripts and your work experience and any current licenses that you have and so on and so forth, and they will forward that. It's called a My NCES record, and they'll just forward that to, if you need to be licensed in Illinois, they'll forward all that to the Illinois Licensing Board and so on and so forth. So it's a pretty nifty tool. Now, this is where you would register for the exam. So if you want to register for your FE exam, this is where you would register for it, pay for it, pick your exam date, and so on and so forth. This is all going to happen here. If you go to the dashboard right here, everything, if you go over here on the right, there's a lot of pretty useful links. Like for instance, this is the calculator policy. Right here is the reference handbooks. So all of that stuff is right here. So I just want to make sure that everybody's aware of this. Any questions? Any questions? Okay. I posted a couple of other things on Blackboard. One of them is the reference handbook. I'm going to skip that for right now. Right now, what I want to focus on are these exam specs. So if you click this, what this is the topic by topic breakdown of the FE exam. Okay, so just so everybody's aware, the FE exam is a 6-hour test and it comprises 110 questions, and the way that it works, So it's split up into two chunks. Like you have a chunk in the morning, you'll take a break, and then you'll have a chunk in the afternoon. It's a computer-based exam, and it will pull from a database of, of questions. It will pull a certain number of math questions, a certain number of prop stats, and so on and so forth. And so instead of telling you you're going to have 6 questions in probability and statistics and 4 questions in econ and so on and so forth, what it'll tell you is this is about how many questions you're going to get. And it can give you a little bit of an understanding as to how big certain topics are. Now, the way that the FE exam used to work is it used to be a paper-based exam, and it used to be 8 hours long, and there was a morning section and an afternoon section, and the morning section was common for everybody. Civils, mechanicals, electricals, industrials, you name it. They all took the same morning exam, and the afternoon was discipline specific. So the afternoon would just be the civils or the mechanicals or whatever. Now, that's gone away. So the exam that you take is just for civil engineers. And that actually gives you a significant benefit. So like, for example, if you look at the difference between, let's say, statics and dynamics, there's a lot more statics on the civil exam than there is dynamics, because where civils, our stuff sits still. Okay? So as a result, there is going to be dynamics on the exam, but it's just not going to be as emphasized as statics is in some of these other topics. So what's on the exam? Here's what's on the exam. Let me zoom in a bit. And so we'll try and review as many of these topics as we can together in Capstone 1. That's going to be our goal throughout this semester, is to try and hit as many of these as possible. I'm not going to review topics for the sake of putting your project back. Like if we need to start some project work early, we will, but I want to try and get as much review done as possible. There's a section on math, that's a pretty big one, and problem stats. There's a section on computational tools, which is basically like Excel. Like if I have a formula and I copy and paste it over here, what's the formula look like? If I have the dollar signs in front of the cells to lock them and so on and so forth. Some ethics and professional practice. So how many of you have me for co-op? So remember the discussion that we had in there? So that stuff. Econ, statics and dynamics. Mechanics and materials, that's just mechanics of deformable bodies, so we call it that here at Marshall. So, there's that. Materials, so this is going to be mixed design, and just a little bit of an extension on mechanics, just like properties of wood and concrete and metals and so on and so forth. Fluids, H&H, so hydraulics and hydrology. Structural analysis, structural design, so structural design, steel and concrete wrapped into one. Geotech, that's a really, I didn't do that. Geotech, that's a really big section, but it's sort of geotech and foundations kind of wrapped into one. Transportation, transportation covers, a little bit of geomatics, a good bit of transportation, and even into maybe some highway design. And then environmental and construction and surveying. So there we go. That is the FE. Any questions? All right. The last thing I want to show you is the reference handbook. So the one thing I definitely want to make crystal clear is that you're not alone in all of this. You have a pretty detailed reference handbook to go along. Now, I don't want you to think of the reference handbook as a crutch, though. In other words, if you, I don't need to study transportation. It's just in the book. I'll just find the formula and plug and chug and I'll be fine. No. Don't do that, okay? Here's sort of the way that I like to describe the reference handbook. And the best way is to look at the math section. So, let me ask you a question. All right, do you know how to take a derivative? You know how to take an integral? Good, okay. Now, who remembers what's the integral of the tangent squared? I'll be honest, I don't remember, I don't need to remember. It's right here, okay, it's at the bottom. So the integral of the tangent squared is the tangent of x minus x, okay? And to me, that exercise is probably the best way to explain how to think of the manual, okay? In other words, You need to understand those basic skills, but you don't need to memorize everything. You do need to understand how to use the manual, but recognize that it's a pretty good resource. So, for instance, what I would say is I really think it's worth taking a second and actually flipping through it and seeing what's available in the manual and seeing what's there and what's not. So let me skip ahead, for instance, to the civil engineering section so that we can sort of get away from all this theoretical stuff and start speaking about things that we're all familiar with. There's a link to it. I'll just put that. By the way, this is a searchable document during the exam. Okay, so for instance, if you go into civil engineering, the first thing you're going to see is geotech. We all had geotech in here. So y'all know what a sieve analysis is. You know what your phase relationships are, air, water, and solid. So weights and volumes, what's porosity, specific gravity, all that stuff. All that stuff is here. You don't need to remember all those little equations, but you do kind of need to understand how that's manipulated. I mean, I guarantee you a very common geotech question is, here's a sample. It was this heavy, and it had this much water, and this much this was its wet weight, and then we cooked it in the oven, and this was its dry weight, and so on and so forth. So what's the porosity? And so you'll have to compute a bunch of different stuff, in order to get that. If I know the volume of the voids, and then I can figure out what the volume of the solids are, all that stuff. And so all those expressions are here. You just need to understand how to employ them. And so here's the section on geotech. We've got consolidation factors. Y'all seen that stuff before, right? So like settlement and whatnot. So this is time-dependent settlement. More Coulomb failure criterion, effective vertical stress, bearing capacity, slope failures, soil classification. I think I kind of know a little bit about this stuff, structural analysis. There's actually not a lot in the manual on just straight structural analysis, because a lot of what we do in structural analysis is just applied statics. But there is a good bit on things like your load combinations. And then, for instance, you start getting into concrete design, and it'll start mentioning, okay, what's beta 1, what's C, what's the formula for your modulus of elasticity, some basics on, well, how do you compute the phi value, how do you compute Mn, for a reinforced concrete beam. This is stuff that you've seen before, right? So, let's see. I just want you to kind of get an idea of what's all in here. So, beam column interaction curves, here's steel design. So there's your CB equation, your moment capacity. This is, for columns. Remember, if you're in inelastic buckling range, if you're in elastic buckling range, so on and so forth. So I'm not going to go through all of this. In fact, I'm sort of intending not to. I really want you to sort of take a second and look through this and see what's available. But does everybody kind of get an idea? Keep in mind, this is a searchable document, but I do think it's a good idea that you have an understanding as to how it's laid out and generally what information you can find. For instance, I'm not sure if you all were aware of this, but like if you go into, let's say, the economics section, you've got your formulas for your discount factors and then tables for all of your, F over A and P over F and so on and so forth. They're there, for various interest rates. So I want you to know that that stuff's there. If you need a periodic table of the elements, it's there. If you need to know what Bernoulli's equation is, it's there. All of that stuff. I just want you to be aware that it's present. Sound good? I'm going to shut up about all the review and get into some math. Okay, let's talk about math. Okay, so we're going to start digging into math, and so this review that I have about 20 questions on math, and I go from algebra all the way to differential equations and everywhere in between. This review is intended to do a couple of things. First off, it's intended to shake the rust off. I mean, we're going to be doing y equals mx plus b, the second order differential equations and everywhere in between. Okay, that's the first thing. The second thing is there are a few questions in here that are intended to illustrate to you that the manual is incredibly valuable. For instance, you probably hear me say differential equations and you're going, oh no, oh God. Like, just sign me up for a root canal. What if I told you that with the manual, the differential equations that you get on the exam is actually probably the easiest section on the exam? Because it literally says, if your equation looks like this, here's the answer. And I guarantee you it does that, okay? So I want to sort of pull the veil off of all of that and make you realize that this is handleable stuff, okay? And the third thing I think I want to get across more than anything is that your calculator. You really need to be familiar with how your calculator operates. There are certain sections of the exam where understanding your calculator's inherent native functions will make your life a lot easier, particularly when it comes to things like statistics. For example, a very popular question on the exam is, here's some numbers. What's the standard deviation of this data set? Okay? Now, to calculate a standard deviation by hand, it's actually a pain. You have to compute your average and then your variance from that and square your variances and add that up and plug it into the formula. You can just plug some numbers into here and hit a button and it will give you the standard deviation. And so understanding how that works will reduce the amount of error that you're going to have on the exam. It will save you a bunch of time. Okay? So understanding, those functions are incredibly important. Now, I'll be honest, I recommend the Casio just because I think dollar for dollar, it carries the most bang for your buck. I don't think that you need to go with something like an HP or anything like that. And the TI calculators are now just starting to mimic this anyways. But you use whatever calculator you want as long as it's approved. There's a link on the NCES account for what's approved and what's not. If you took Engineering 111 and I'm looking front row and everybody here has Casio, so you're good. So I'll sort of move past that. Let's do some problems. Now this is bringing it back. Problem 1. What is the length of a line segment with a slope of 4/3 measured from the y-axis to a point 6,4? Now, this isn't a hard problem if you're currently taking algebra, but if it's been like 4 years since you've been in algebra, you're like, damn, where do I start? And the volume of your laughter indicates to me that some of you are like, damn, where do I start? So, let's just sort of take this one step at a time, okay? And part of this review is me just walking you through this. Like, this first question is purposefully involved to sort of like shake the rust up, okay? So, let's just take some of this data, okay? I have a slope of 4/3 and I have a point that's 6,4. What can I do with that information? Let's ignore what the question's asking, and let's just ask that. I have a slope and a point. What can I do with that information? Well, I can come up with an equation for the line, right? Now, how do we do that? What is it? Y minus y1 equals m times x minus x1, right? And so I have y minus 4 equals 4/3 x minus 6, right? Okay? And so what do we have? Y minus 4 equals 4/3 x minus, so 4/3 times 6 is 24/3, which is 8. And so that's y equals 4/3 x, what is that, minus 4? Did I do that right? Now that isn't too bad, right? That's the simple part. Okay, so what is the length of a line segment with this slope measured from the y-axis to this point? Well, what I can tell you about this is that is the equation of the line with that slope, and it goes through that point, right? That's what that equation is, okay? So I need to know what's the length between essentially 2 points. this point and wherever it crosses the y-axis. Where does it cross the y-axis? Well,
-4, x equals 0.
there we go. X equals 0 and y equals what? -4. That's what B is, right? So what I've basically got is this point and this point. And so how do you determine the length of a line segment between 2 points?
Square root of y2 minus y1.
There you go. Exactly right. So the distance is the square root of y2 minus y1 squared plus x2 minus x1 squared, right? It's just basically the Pythagorean theorem. So square root of, what do we have? We have 4 minus -4 squared plus 6 minus 0 squared. So that's the square root of 8 squared plus 6 squared, which is the square root of 64 plus 36. Square root of 100, which is 10. Admittedly, that question was a little difficult, okay? If you're not in algebra. Like if you were currently in the class, that'd be pretty doable. But since it's been a while, it's like, where do I start? But it's really not that bad, is it? Any questions? All right, let's keep on trucking. All right, here, do you want me to leave this up for a bit? Just let me know if you need me to leave this up. I'm good for that. Okay. All right, problem 2. What's the general form of the equation for a line whose x-intercept is 4 and whose y-intercept is 6? Now here's the thing. Let's look at this, okay? What's the general form for the equation of a line? You might not remember what the general form of the equation of a line is. This is, you know, each of these questions are sort of formulated to make a few points. And so let's take this one. You might not remember what the general form of the equation of a line is. Who cares? You got 4 choices and some info. Just do some algebra to make your answer look like one of these, and you'll find which one it is. Okay? And so if that seems a little weird, just bear with me. Okay? Now, I have a line whose x-intercept is 4 and whose y-intercept is 6. So in order to generate the equation of a line, you either need 2 sets of information. You need a point and a slope, or you need 2 points, right? Because with those 2 points, you can determine a slope, right? So let's look at those 2 points. What are the 2 points that we know? Well, we know the x-intercept is 4, and we know the y-intercept is 0. So we've got 2 points. So we have 4, 0, and 0, minus 6, right? So with those 2 points, I can get a slope. And how do I do that? Change in y over change in x, right? So what do we have? We have minus 6 minus 0 over 0 minus 4, which is negative 6 over negative 4, 3/2, right? So there's the slope. Now I could do point slope, right? I could do y minus y1 equals m times x minus x1. But when I have y equals mx plus b, what's m? M is the slope, right? What's b? And what's the y-intercept? Negative 6. So I propose that the equation of this line is 3/2 x minus 6. That's the equation of the line. Now, I propose to you that this is the answer, okay? It's just not in the right form. Well, how do I get it in the right form? Let's make this look like these. So what's different? Well, the first thing that's different is that everything's on one side of the equation and they're all set equal to 0. So what I can do is I can just take y, move it over there. The next thing is that there's no fractions. So how would I get rid of the fractions? Well, how about multiply everything by what? 2. So let's do that and let's see what we get. Now, before we do anything, before we even do any math at all, we can do some elimination. I mean, we know that the constant is negative, right? So it can't be b and it can't be d, right? Because here, this is positive 18 and that's positive 12. So right off the bat, you can eliminate 2. And if I multiply everything by 2, that's going to be 3. So we don't even have to really do anything. I can tell you the answer is going to be C. But if I go ahead and carry that out, this times 2, that's 3x. This times 2, that's 2y. This times 2, that's 12. So you can seriously do some sort of question investigation and choice investigation in order to make the process a little easier. You may not remember what the general form of the equation of a line is. That doesn't matter. Just look at the choices. This is what it looks like. Remember, it's ax plus by plus c equals 0. So just rearrange the equation so that it looks in that fashion. There you go. Yeah. All we care about is getting the answer right. This isn't a math course where you have to follow that process and system parameters and all that stuff. We're just after A, B, C, or D, okay? And I'm going to be completely honest with you. When I took the exam, there were questions, I've gone through it, and there was that one question, I'm like, I do not know how to do that question. And I looked at my answer sheet and I went, haven't guessed A in a while. And so, I'm going to be honest, I don't think that's the worst idea in the world. If there's that one question you can't figure out. Now, if you're doing that for 60 questions, that's a problem, So, all right. Okay. Anybody remember these? Logarithms. Right? Now, first off, if you don't quite remember how to do these, the first thing I would say is I would bet your calculator will just do this for you, right? You can just plug and chug, okay? So first off, I can tell you that there are plug and chug questions on this exam, just right off the bat. I guarantee you, just about every single person in here who takes this exam will have a definite integral. Tell me what the answer to this definite integral is. Gonna happen, guaranteed, okay? Some of these, like this one, you can probably plug and chug into your calculator. Now, if you don't have a calculator that does this, or you can't remember, let's go back to some, fundamental properties of logarithms, right? So, we have base 3 log of 3 halves plus the base 3 log of 12 minus the base 3 log of 2, right? And so, if you remember, if you have the log of A minus the log of B, what that means is the log of A over B. Alright? And so that's going to be 6. And so if you have the log of A minus the log of B, that's the quotient. If you have the log of A plus the log of B, that's a product. So we're going to have the log of 3 halves times 6, which is going to be the log of 9. All right? And what is a logarithm? Let's just go back to fundamentals. A logarithm, what that basically means is we're trying to figure out 3 raised to some number equals 9. And so 3 raised to some magic number equals 9. That magic number is the answer to what is the base 3 log of 9. So what is the base 3 log of 9? 2. Now, for you folks with your fancy calculators, were you able to just do it?
Yeah.
Okay, all right. So, a couple lessons to be remembered. First off, your calculator might do a lot more than you think. Second, you can probably manipulate it a bit on the page. Now, let's say you don't remember these rules of logarithms. Where do you find them? In the reference manual. Let's pull that up. So mathematics, logarithms. Here we go, right here. The log of x plus the log of y is the log of x times y. The log of x minus the log of y is the log of x divided by y. So they're right here in the manual. And where are they? They're under this thing called logarithms. So if you hit Control F and you type in logarithms, there they are. I mean, you can Control F during the exam. So I don't want you, here's sort of my point. I don't want you to see a problem like this that's like logarithms and go, oh, I don't remember how to do that. Don't approach it that way. It's there, you know. So take a step back and go, I can do this, you know. I am capable. I am a strong civil engineer. Control F. You know those memes. It's like, you know, what my parents think I do, what I think I do, and what I actually do is just Google. Okay, now this one's hard. I'll go ahead and tell you. Okay, so it's hard without some of what I would call Dr. Michelson's tips and tricks. For problems like this, so first off, I'll go ahead and tell you that this isn't a problem where I don't think that your calculator is just going to solve this one for you, okay? This is one where you got to do a little bit of thinking, okay? And so one of Dr. Michelson's tips and tricks when it comes to trig problems is that whenever you're confused or not really sure where to go about things, get it in terms of sines and cosines, okay? Every trig function can be simplified into sines and cosines. The tangent is just the sine over the cosine, okay? And so by getting things in terms of sines and cosines, you can generally figure out where to go from there, okay? And so the first thing that I see here is a cosecant. What can I do with that cosecant? What's the relationship between sines and cosines if I'm talking about a cosecant? If I flip the cosecant, I've got the sine, right? Because remember, the sine and the cosecant are inverses, and then the cosecant and the secant, or the cosine and the secant are inverses, right? So right off the bat, I can say if the cosecant of theta is minus 8/5, then the sine of theta is minus 5/8. Okay? And so that gets it into sines and cosines right off the bat. So take my known quantity and convert it into something I can deal with. Now, there's a couple ways of going about this. You could say, okay, I've got the sine, so I could take the inverse sine and then to get the angle, and then, you know, take the cosine of 2 times that. What I want to do is I want to avoid that a bit and go into trig identity land. Remember all those trig identities? It was like, well, if I have the cosine of A plus B, that's the cosine of A, cosine of B. Remember all that stuff? They're in the manual. So I'm after the cosine of 2 theta, okay? So if I'm after the cosine of 2 theta and I know the sine, maybe what I ought to do is go into the manual, go to these trig identities, and ask myself, okay, here's the trig identities. I'm after the cosine of 2 theta Is there an expression that'll get me there if I know the sign? Well, the cosine of 2 theta is 1 minus 2 sine squared of theta, right? So it's right here among all of these. So what I can say is, therefore, the cosine of 2 theta is 1 minus 2 sine squared of theta. So that's 1 minus 2 minus 5/8 squared. So 1 minus 2 times 25 over 64. 1 minus 25 over 32, which is 7/37. Now, did that match what you got if you invert that and then take the cosine of 2 times that? So yeah, that works too, but I'm also trying to be a little holistic in my review and cover a bunch of stuff. What do you think? Yes?
Would you recommend doing like something like this, like working it out by hand? Because if you know like the property, like 1 over sine is whatever, viscosity. If we put in 1 over sine of x and use the solver function instead of equal to negative 8 over 5, it gives you the value of theta, and you can just plug it in that way.
You could do that.
Would you recommend to actually work it out? Is there any negative to using the solver function?
No, there isn't a negative to using the solver function if you're comfortable using the solver function. And so all that does is reinforce one of my original points: know your calculator. There are a lot of inherent tools in your calculator that will make your life a lot easier. But if you don't remember those tools or how to do them, then you got to go off this. So I guess it just depends on how comfortable you are with your calculator. Some folks are going to be comfortable with using those native functions, and some aren't. And I'm gonna be honest. Like when I took my exam, me and my TI-89 were buddies. And so I had to take that TI-89 and sort of put it off to the side. So when I came to the exam, I made it a point to learn the calculator that I used for the exam, but at the same time, I wasn't as comfortable with it as I was my graphing calculator. So I think I was probably at a little bit of a disadvantage, and there were probably some inherent functions in my calculator that I used for the exam that I just didn't know. So I did a lot of my problems the hard way, So I'd probably avoid that, but at the same time, what if this was x? Like the cosine of the angle was x. You'd still need to know how to do this stuff because your calculator isn't going to be able to tell you how to do that. So this is good stuff, though, to think about. So, one thing I will say about solver functions, I think sometimes you got to be a little careful about positives and negatives in terms of context. Here's a good example. How many of you remember in concrete design? Did everybody here had concrete design? I think for the vast majority of you did. There might be a couple of you that didn't. When we solved for C, for like the neutral axis for where the beam was, you'd get a quadratic equation. So you'd get one answer that was positive and one answer that was negative, and the negative answer didn't make any sense. Because here's the beam, and C is measured from the top, and so you do your quadratic equation, you get C is minus 4 inches. Well, it didn't make sense for C to be above the beam, so it had to be in the middle. So you always took the positive answer. So just what I would say is be careful on an exam like this using those solver functions, because they'll work, but they work following just straight rules of mathematics. And especially when you get into civil engineering land later on in the exam, you need to make sure that you're using the values that have appropriate context. Don't just, because if you just pulled the negative value and started, doing the rest, you probably wouldn't make any sense. So. Does that make sense? Okay. Speaking of, I didn't do this full screen, so, oh well, okay. All right, so speaking of, here's one of your expressions that you can't simplify via the calculator. You've got to do the math. This goes, again, into my advice. Break this down into sines and cosines. So the cosecant of x, that's 1 over the sine of x. The cosine cube is the cosine cube. Don't have to mess with that. And then tangent, that's sine over the cosine, right? So that and that cancel, and I have a cosine cubed divided by a cosine, so that's a cosine squared. Now cosine squared is not one of these answers, okay? But we still got to figure out one. Does anybody offhand remember any identities regarding the cosine squared? The sine squared plus the cosine squared is 1. So if the sine squared plus the cosine squared is 1, that would make this 1 minus the sine squared, right? Because I have to add the sine squared on the other side, and that would be 1. So let me ask you this. Did that seem like an easy problem? Now, if I had done that on problem 1, would it have sounded pretty tough? See, it's all about shaking that rust off. See, it's not so bad once you get back into the swing of things, okay? It really isn't. Yes?
There's like several of them, we got them into a form of an answer that is the correct answer, but it's just in a different form. How many of the questions on the actual exam, the answers come out to be like correct, but in a different form?
I would say that on the math section, that's very common. Another place where that's very common, and I'm just going to tell you right now that you'll want to get familiar with this, is units. You will very likely get an answer that's a moment in foot kips, but the answers are all in inch kips. That happens all the time, okay? So math sections and units are where that's going to happen most often. But when you start getting into your, like applied fields, I don't think that's going to be the case. What's the flow rate? It's 1,200 gallons per minute or whatever. That's the answer. It's not going to be this. That's a good question. Anything else? It's good stuff. All right. Okay. What's the value of x that will satisfy the following equation? Okay. I kind of like this problem. First off, so I have the sine squared plus 4 times the sine plus 3 equals 0. Does that look like a different, there's a bunch of sines, but what does that look like? It looked like exactly what you said. I think you were going to say it looks like a quadratic, right? You've got a pile of junk squared plus a number times a pile of junk plus something equals 0. So why don't I just say, let's let like a equal the sine of x. So therefore, that's a squared plus 4a plus 3 equals 0. Now, what can I do with that? Can I factor it? Y'all remember that?
Yeah.
So we have an A. Then we look at the 3, right? And we ask ourselves, how many different ways can 3 break down? And 3 is a prime number, so it can only break down into 3 and 1. And 3 is positive, so they either both got to be positive or they both got to be negative. So they're both positive, and that works out because 3 plus 1 is 4. So what that means is that A either equals minus 3 or A equals minus 1. Everybody okay with that? Or, now, going back, that means that either the sine is minus 3 or the sine is minus 1. Right? Okay, now I'm curious. What do we do with this? We got 2 different answers. Can anybody think of anything to say about any one of these answers? What can we say about this?
It's over 1. Can never be greater than 1.
Exactly. The sine can never be larger than plus or minus 1. Like, you can't exceed that. Remember, what does the sine look like when you graph it, right? Here's the axis, this is x, and that's y. And so the sine function does, that whole thing, where that is plus 1, and that is minus 1. So the sine function can never be 3. Like if you take the sine of any angle, it's always between plus or minus 1, right? So that answer doesn't make any sense. But this one does, right? When does the sine equal minus 1, right? This is 0, that's pi over 2, pi, 3 pi over 2, right? So it's and 3 pi over 2 is how many degrees? 270. That's a little bit of a tricky problem, but I just like it, so I do it. I kind of like that problem.
So if the Casio solve, it gives you negative 90. Yeah.
And then negative 90, that's a good point. So if you plug it into the Casio, and Casio just solves it out, it gives you negative 90. Well, negative 90 is the same thing as 270, right? Because you think of a unit circle, we're either going down 90 or going positive 270, right? So just something to keep in mind. Speaking of, what about this? Oh, you know what? I'm going to let you all work on this one.
Oh God.
C.
Now, here's the thing. Here's the thing. You could probably, I know you can eliminate one choice right now, and you could probably eliminate 2 if you thought about it. What choice can you eliminate without doing any math?
D.
Not D.
Because it's different.
No, there's one that's different.
A.
A. Why can you eliminate A? Remember how polar coordinates work. You go out and then an angle. You can't have an R value that's negative. So that doesn't make any sense, you know? And then what you could do for the remaining ones is you could ask yourself, well, what quadrant is that going to be in? What quadrant is this going to be in? 3, right? And so this angle, that puts you in the 3rd quadrant, right? Because here's your coordinate system, and that's 90, and then 120. This one doesn't, right? C puts you in quadrant 2, doesn't it? Because you go out, then you're up 90, and then over a little bit. So right off the bat, we can eliminate A, and we can eliminate C. So all we have to do is figure out which one. Is it B or is it D? Y'all remember this? Did they not? Did they do?
They did.
That's nice, but it's had a calc 3 teacher.
X equals. I think he would be.
Peter.
X B C.
Good, Peter.
See, part of me just wants to leave the ambient microphones on just to capture this banter.
We have X.
It's funny.
So we can do R plus theta and see what.
What's that? All right, so
Yes.
let's do this. Okay, so let's do this. Let's draw this out. Okay, so what does our vector look like? We go over 3 to the left and down 5.2 to the right, right? So if I try and draw it in scale, that's probably like something like this, right? Okay? Fair statement? So, this is minus 3, that is minus 5.2. Now, how do we measure our angle? We start here, and we either go up is positive theta or down is minus theta. So this would be the way that our angle is going, that's minus theta. So if I draw that to scale, does it look like that from here to here, does that look like 120 degrees or does it look like 150 degrees? Say it again?
120.
That's exactly right, it's 120. Now, so what I'm after is I'm really after that angle. That's the angle I'm after, right? Okay, so it's going to be 90 plus whatever this is. And so how do I figure out what that is? Well, here's my triangle. That's the angle I'm after. This is 5.2. That's 3. So how do I figure out what that angle is? There we go. The tangent of theta is 3 over 5.2, right? Opposite over adjacent, SOHCAHTOA. So therefore, theta is the inverse tangent of 3 over 5.2, which is, it should be 30. Right? So when we look at our polar coordinates, the angle is going to be minus 90 plus whatever this is, so 90 plus 30, the angle is minus 120. As for the radius, I could compute it, but do I really need to go through the bother of doing 3 squared plus 5.2 squared and take the square root? It's 6. There's no other choice. It's 6. So that's another thing when it comes to this exam. Don't waste your time. It's 6. I promise you.
It's like an angle 16.
No. Remember, our values are always positive. If it was negative 6, it'd be like imaginary or something. I don't know. All right. Sound good? So before we move forward, are you feeling better about this? Worse? Okay. Oh. Uh-oh. A circle. Determine the x and y coordinates of the center of the circle. Y'all remember this? Nobody, did anybody do this?
Our good friends H and K.
H and K, there, okay, all right. So, let's say you don't remember this. First off, if you don't remember this, what's the answer? The manual. So first off,
Yeah, all right.
so let's go to the manual. All right, and so let's go to the front page. Let's go circle. Bam. And so if you don't remember this, or if you haven't seen it, and it's possible you haven't. So some folks, some high schools, they cover this in pre-calculus, some of them don't, some of them cover it in algebra, geometry, some of them don't. This can be a little wishy-washy, just depending on where you went. How many of you have heard the term conic section? Maybe you've heard that. Okay, if you haven't heard that, so basically what a conic section is you imagine two, I'm going to see if the image is in the manual. If it's not, I'll draw it up here on the board. Yeah. Okay, so the way a conic section works is you imagine two cones that are on top of one another, intersecting at a common point, and then imagine a plane passing through it. Using that plane, you can actually identify the main fundamental graphs in mathematics. So for instance, if the plane cuts perpendicularly through, what does it look like? What does it cut through? It cuts through a circle, right? If it cuts at an angle, that's an ellipse. If it cuts along here, that's a line. If it cuts through the middle, that's a point, okay? If it cuts up and down, that's a hyperbola. So you can identify the fundamental graphs in mathematics through what's called a conic section. And so when you see something on the test that's like analytic geometry, this is like one of the things it's talking about. And so there are fundamental graphs in mathematics that we call conic sections. The equation of a line, the equation of a circle, the equation of an ellipse, a hyperbola, so on and so forth. And so, let's see. So the parabola, all of these are fundamental conic sections. So the fundamental case of a circle, the way that we represent that graphically is the following equation. X minus h squared plus y minus k squared equals r squared. And so the nice thing about putting the equation in this form is that r is the radius of this circle, and then h comma k are the coordinates of the center. I mean, what is a circle? It is the set of all points that are equidistant from the center, right? That's what a circle is. So that's the nice thing about this expression, is that it just tells you what the circle is by just looking at it. Now, here here is our problem. Here's the equation. We kind of need to get the equation in this format, okay? So the equation of a circle is x minus h squared plus y minus k squared equals r squared. So we kind of need to get all the numbers on one side and all the variables on the other. So the first thing I'm going to do is I'm going to take this 25 and I'm going to move it on over to the right. So x squared minus 8x plus y squared minus 10y equals minus 25. Okay. Now, in order to write this in this form, I have to engage in a process called completing the squares. Everybody remember that?
Yeah.
Okay. So here's how, oh, this is bringing it back, right, isn't it? So here's how completing the square works. Okay, so what I'm going to do is I'm going to take this equation and I'm just going to spread it out. I'm going to write it over a bigger line. So we have plus y squared minus 10y equals minus 25. Okay, so here's how you complete the square. It's really not that difficult, and I'll show you how it works. Let's take this part right here. What is half of 8? 4. What's 4 squared? 16. So what I'm going to do is this. I'm going to add 16 right here. Now, laws of algebra state that if I add 16 on one side of the equation, I better add 16 on the other side of the equation. Now, why did I add 16? The reason why I added 16 is factor that. What does that factor into? So this is x, this is x. So what does 16 break down to? It breaks down to 1 and 16. That isn't going to work. 4 and 4. So this breaks down into 4 and 4, and they both got to be negative, right? So that breaks down into x minus 4 squared. That process is called completing the square. You're adding that magic number so that when you factor it, it'll factor into a perfect square. Okay? That's what completing the square is. So what's that magic number here going to be? 25. So what I'm going to do is I'm going to add 25 here, but if I add 25 to one side of the equation, I have to add 25 to the other side of the equation. So that's going to factor into y, so that's going to be 5, 5. They're both going to be negative, and so that's going to be y minus 5 squared. So don't forget my plus, equals. And so what do I have over here left over on the right? Negative 25 plus 16 plus 25 is 16, and 16 is simply 4 squared. So this equation is the equation of a circle that has a radius of 4, and the coordinates of the center are 4, 5. I hope that wasn't magic. And even if it like you haven't seen that or whatnot, it doesn't follow or it doesn't require any like crazy rules of algebra. I mean, if I add a number to one side, I have to add it to another. That's basically what's going on. If you have a conic section problem like this on the exam, anything that references like the equation of a parabola, the equation of an ellipse, the equation of a hyperbola, things like that, chances are what you can end up doing is just getting it into the form that's in the manual, and your answer is probably going to be pretty revelatory, in other words. Is everybody good? Okay. Now we've crossed into a different world. What world have we crossed into? We're in calc land. What is the slope of the curve when it crosses the positive part of the x-axis? Uh-oh, we're in calculus land. Okay. First off, how do we determine the slope of a curve? Like what do we do? We take the derivative. All right. The derivative of this function, so what is the derivative? Okay. And so that derivative tells us what the slope of the function is at any point along the function. Now it's asking for when the curve crosses the positive part of the x-axis. So let's digest that for a bit. When you cross the x-axis, what's the x value? Or what's the y value? Sorry.
0.
0. So we need to figure out what values of x will make y equal 0. So why don't we set this equation equal to 0 and solve for x. Let's see what happens. So if I set this equation equal to 0, so 0 equals 10x squared minus 3x minus 1, I will be heartbroken if you don't know how to solve this, because that's going to be x equals 3 plus or minus the square root of minus 3 squared minus 4 times 10 times minus 1 all over 2 times 10, right? Quadratic formula. So that's going to be 3 plus or minus the square root of 9 plus 40 over 20. So that's 3 plus or minus 7 over 20. So either x equals 1/2 or x equals minus 1/5. Did I do that right? So the question is asking, what's the slope when it crosses the positive part of the x-axis? Well, it crosses the x-axis twice, here and here. So which one do I care about? 1/2. What's the slope when x equals 1/2? Plug in 1/2. So therefore, what do you think? In fairness, that one's a little tricky of a calculus problem, like just the way it's worded, and I'm sure it's like, whoa, that took me for a loop. But does anybody have any questions about that? Okay. This one is probably a little more of a standard calculus problem, I would say. I mean, you know, there's two fundamental questions that calculus asks. What's the slope of a curve, and what's the area under a curve, right? The derivative will tell you what the slope of the curve is, the integral tells you what the area is. That's what calculus is. Fundamental theorem of calculus says that derivatives and integrals are inverses of one another. So that's calculus in a nutshell. Unless I'm mistaken, the way that typical calculus classes work, right? You learn about limits, then you learn about derivatives, then you learn about applications of those derivatives before you start getting into integral land, right? And one of the applications of a derivative, or the derivative as a tool, is it will tell you how to graph a function, right? Because you can figure out what the slope of the function is, you can figure out its concavity, what the maximums are, what the minimums are, and you can graph that curve with relative accuracy just using those tools, right? So here we have a curve, and it's asking us what's the maximum value of that function on the interval x is less than 0. So on the negative side of the x-axis, what's the absolute maximum value that we're going to see? So here's how I'm going to handle this. So we're going to need to take some derivatives. So first off, we're going to take the first derivative. So what is the first derivative? 6x squared.
Plus 24x.
Okay? And then we're also going to take the second derivative. Now, why are we taking the second derivative? Okay? Well, the first derivative, what will the first derivative give us? The first derivative will give us extrema values, right? Local extremas, right? So we take the derivative, we set it equal to 0, we solve for x. It will tell us where the slope of the function equals 0, right? But it doesn't tell us whether the function is opening downwards or opening upwards, right? That's what the second derivative tells us. The second derivative tells us the concavity of the function. So if we plug in the first derivative and we get it opening downward, that tells us that that's a local maximum, right? So we need the first derivative and we need the second derivative. So the second derivative is 12x plus 24, right? Okay. So how does this work? Well, we need some local extreme values. So we set the first derivative equal to 0. So solve for x. So 6x squared plus 24x minus 30 equals 0. There's a lot of 6's in there, so x squared plus 4x minus 5 equals 0. That factors into, so 5 and 1. That combines to give me 4 if I make that positive and that negative. So x equals minus 5 or 1, right? So we're talking about the interval on the negative side of the x-axis, right? So on the negative side of the x-axis, I don't really care about this, right? So I don't care about that. So let's focus our attention on this. So that is where a local extreme occurs, but I don't know whether or not that's a maximum or a minimum. So I plug that value into the second derivative. So plug minus 5 into f double prime of x. So that's what? 32? Not negative 32? Wait. Negative 36. So what does that tell you? Somebody tell me, what does that tell you? It opens downward, so that point is a maximum, right? But what's the answer? The question is asking for what's the maximum value, okay? This is where that maximum value is, and this tells you that it's a maximum. But these aren't the answers. What is the maximum value? What do I do? Plug it into the original equation, exactly. So therefore, f of minus 5 is 2 times minus 5 to the third plus 12 times minus 5 squared minus 30 times minus 5 plus 10, and that equals what? That's calculator land for sure. What's that?
Well, we could make 2 guesses.
You're right. But here's the thing. It could just by coincidence be negative 36 or minus 5. It's possible, you know. But it's not.
2, 2.
Positive 210?
Positive.
Second? Okay, so positive 210. Now, a couple things about this question. The interval was x then less than 0. If the interval was x less than or equal to 0, remember how when you're looking at a given range, you want to check the ends of that range to see if there's a value that's larger, right? You can have a function that looks like this, and here's your local, but you could have something that go like that, and that's actually a larger value than this one. But because it's less than and not less than or equal to, that end point doesn't really occur. That doesn't mean that couldn't happen, but not given the derivative test. So yeah. Any questions?
The negative 36. The negative tells you it's concave down.
Yes.
36 tells you. Okay.
Yeah. The negative 5 is where it's at, and the negative 36 says it's opening downward. Okay? This is the actual maximum, the actual peak. So if we're talking about like a mountain, like if you're driving down the road, this says it's 5 miles down the road. This says it's a peak and not a valley. This is the elevation.
Okay.
Yeah. Civil engineering terms, right?
Yeah.
What do you think? Any questions? All right. Here's what I'm going to do. We got 10 more minutes, but I'm good if you are. Here's what I do want you to do from here on out. And I actually encourage it. If you got a laptop, bring it. Why? Because when you take the computer-based exam, you're going to have the manual there. So having the ability to search the PDF while we're doing these problems in class is probably a good thing, okay? What I'm also going to do is push that math quiz back a week. We're not done, and I'm not going to give you a math quiz while we haven't finished everything, okay? Again, do me a favor, go through that topic poll and tell me where you're at in terms of your desired emphasis area, and we'll move forward from there. Yes, sir?
Will you post the problems out?
They should already be there. I just turned on. It should be there now. Are they there? Okay, they're there now. So I had them turn on like at 4 p.m. So sound good? Sign in sheet if I didn't get it. I need that back. That's all I got. I'll see y'all next week.
Because you're only set between the two because that's how they say it.
I mean, they're so around.